Hello everyone, this is 𝐒𝐲𝐬𝐿 𝐃𝐞𝐬𝐬 and I am back with another architectural discussion in which we will be picking up one of the architectures from booking.com. Booking.com, if you don't know, if you are not aware of booking.com, it's basically a website or platform where you can book hotels, accommodations, any kind of flights, so all those things, all kind of bookings you can do whenever you are planning a travel, any kind of travel whichever you are planning, you can use booking.com. So specifically, like how different accommodations, like I mentioned, right, you can book different kind of accommodations. It could be homes, it could be hotels. So all those things, they first has to be onboarded onto this system. Okay, there are multiple clients, or you can say multiple hotels or multiple homeowners which come to booking.com and onboard their properties, onboard their hotels, onboard their houses. So what is the architecture for that property onboarding? So that we will be discussing today. But before we move forward with our discussion, few things. First thing is, if you haven't subscribed to the channel MsDeep Singh yet, on which you are watching this video, consider subscribing. You will see lot of these kind of architectural discussions. You will learn lot of these things. So consider subscribing. And another thing is this upcoming book, which is System Design on AWS. So as and when I make this video public, this book should be out, and this is written by written alongside with one of my co-author, which is Jayanth Kumar. It's System Design on AWS. You will learn how to design systems along with the concepts in correlation with AWS. So it's a great architectural deep dive of different architectures, and one of the chapters is related to designing hotel reservation system as well. So in that chapter you will learn also this property onboarding. Alongside, you will learn about how the payments are done, how different things are handled whenever a property is booked. So this will be a great help to your everyday design decisions. Now moving back to our whatever we started with, property onboarding architecture. So the first of all, what we want in our architecture, right, we have some sort of requirements which are needed. So first is like manual process is hard to scale. Now you can't go to doors of each and every hotel owners and then ask them for details, right, and then onboard to your system. You need some kind of automated process, right? So since there are a lot of homes which are onboarded and it is spread across the countries, multiple countries, so you need some kind of automated mechanism. So self sign up tool for registration, and there are as like there are multiple steps which are done during the onboarding. It could be as simple as, let's say, enter the location. Okay, enter the location, enter the property details such as number of rooms, what kind of facilities, different kind of pricing structure. Okay, how far, and like all lot of things which are needed, which are taken input from these owners. And once that input is taken up, they are like these details are moved to the booking.com platform or like a backend system in which they are saved and then available to the searching. Like whenever the users, this handsome user Mandeep, whenever this user comes up that, yeah, I'm going to this particular location, give me the hotels for this location, so he will go to the booking.com website and then search for it. So whatever the users were like for that location onboarded to it, they will be displayed here. So I can select one of them and then go ahead with the booking of these properties for the particular selected date range. So this is the overall, you can say, requirements per se, right? We need a self sign up tool, or you can say automated kind of mechanism in which users can come in, onboard their properties, and those properties are then listed on the search page whenever the users are searching in that particular location or by searching via that particular property name. So this is how our architecture looks like. You have your user, as I said, right, it's a handsome user Mandeep who is trying to book a property, not trying to book a property. Now right now Mandeep is trying to do. Mandeep is trying to register a new property because he also wants to earn some money through these hotels and all. Okay, so then there is a registration process website. As I said, there are multiple details which need to be entered. Once the details are entered, the request is put up in a queue. Okay, this requests are put up in a queue, and then these requests are pulled up by this property builder processor, or you can say a simple service which is running. It pulls up the messages from queue and then execute these steps. Okay, so there are like 30 odd steps which are executed, and then they are processed or like saved. Now there are a couple of issues with this architecture. It's great, okay, like issues are not great. The architecture is pretty simple. You take in the steps and then process them. The data is finally saved to your database. Okay, and let's say it is pushed to also Elasticsearch. In backend it uses Elasticsearch, and then whenever your search happens, they are pulled up from here. Great architecture. Now there are a couple of issues which are associated with this architecture. Okay, and the issues are related to how the data is processed. So the first thing is, if you observe, all the data is taken in one go. All the data is taken in one go. So even if the data is, let's say, lost in the front end website, now user has to enter details all again. Okay, there is no such mechanism that okay, these details were already saved, now you can move further from it. Okay, that's one thing. Another thing is, if we talk about the backend architecture, it is executing these 30 steps all together. Now even if a single step fails, let's say you were able to execute 25 steps, okay, successfully, and then 26 step failed. Now if this step failed, you will have to again start from the zero. That's not a great architectural decision, or like how you implement our system. Okay, you don't want that execution to repeat. What you want to do is, if the 25 steps were executed successfully, you want to just retry for the 26th. So that was one of the issue. Another thing is, like, it also adds more time because you are retrying for the entire workflow. Okay, so it takes more time for property unlisting, and it also adds operational overhead. Why operational overhead? Why operational overhead? Because in the scenarios, if something goes wrong, it's hard to debug the issues out. Let's talk about the improvements. How can you improve this current architecture? How can you do it? In the 30 odd steps, there are three steps which are very bulky. So the first idea would be, can I extract these three steps out? Okay, just execute the 27 steps together, and these three steps should be taken out separately or executed separately. This should somehow help to simplify architecture. So what was the improvement which was done here? The improvement was that, let's say earlier we had your this code base for 30 steps. So what we will do, we will extract the code for these three builders, or you can say three steps separately, so that it simplifies this architecture, and also it has this independent logic which is written in these three steps. So how you do it, you publish or you push those logic or like execution of these three steps to a separate queues. Okay, you are maintaining a three separate queues in which you push that, yeah, execute this particular step. This step processor will pull this message or like extract this message, and once that is done, it process that message, and then finally the data is saved to the database. Now it somehow simplifies the architecture, but you're also adding an overhead of 3 additional steps. Okay, so there is a scope for further improvements. Now if we talk about these kind of architectures, right, if you talk about like these kind of requirements, if you talk about these kind of requirements in the system architecture, the general idea should be, you have certain steps which has to be executed. Okay, step 1, step 2. Now it might be possible that some steps are correlated and some steps might not be. Okay, so there is a possibility that, let's say, first step should be executed before step 2. Okay, so there could be some correlation, or there is a possibility that they are completely independent steps. Okay, example could be, let's say, first you have to add the property name and all those things, once the property is added, okay, then you add rooms to it. Okay, so it's just a simple example, but there is a possibility that some steps could be correlated, as in like they should be executed in certain fashion, or they could be completely independent, so it doesn't matter if they are like whichever is executed first. So this overall idea, the general paradigm of decision making here would be that how you should implement them. You should implement them via some workflow execution, okay, workflow executor or workflow mechanism. Okay, so you are basically executing certain set of steps, and it's kind of workflow, right? You are executing certain set of steps, and they can be executed via a workflow system. Now, if I mentioned that it's a great book, System Design on AWS, you will also learn about there are two kind of workflow paradigms. One is orchestration and one is choreography. You will also understand what's the difference of them, what's the difference between them, and what's the pros and cons, because there are always pros and cons associated with every architecture which you choose. So for a workflow execution, okay, workflow execution, orchestration basically says there is a central orchestrator. There is a central orchestrator which manages all these steps. Okay, there is some step orchestrator which manages all these steps. And in case of choreography, what happens is that once the step 1 is executed, it sends the message to a, let's say, some general queue, and then it is responsibility of step 2 to listen to that execution of step 1 is completed, and then start the step 2. So in case of choreography, there is no central coordinator, central orchestrator or coordinator or central component which is managing all of them. So in this case we are using a workflow orchestrator, and Booking.com started with using Netflix Conductor. There is a blog post by Netflix as well, in which they discuss about this architecture of Conductor. So, and they also recently published one new blog which talks about a new workflow execution orchestrator, which is Maestro. So you can check out that as well. But I'm not going into that specifically. The idea here is that you define the steps into the workflow steps. Okay, you define those steps, and what you can do is this particular step, let's say this particular step, you can mention that to execute this particular step, call this HTTP endpoint. This endpoint could be anything, but let's talk about, let's say it's a HTTP endpoint. So you forward that request to HTTP endpoint, and once that request is completed, now there's a possibility, I think I'm going too much into the details, but let's quickly wrap it. So it could be possible that it's a sync call, it could be a async call. So if it's a sync call, then it will wait for that HTTP endpoint to send a response. If it's, let's say, it could take much more time. So in that case, async could be used, in which once the response is, or like the execution is completed, this HTTP endpoint should reach out to this system again to respond that yeah, the execution is completed, you can further move to further steps. Okay, so it's great. If you see, it has completely decoupled the architecture. You can execute the steps independently, and you can maintain these code bases independently as well, however you want to maintain them. So what are the benefits? Configurable workflow with instant changes. You can configure the workflow and it reflects the changes instantly. One important thing in workflow execution, like one problem which we mentioned, was operational overhead. Why? Because it was hard to debug in case there were issues happening. Okay, so you have a good UI, to visualize these steps. Okay, visualize these steps, as in, let's say these are my steps which are being executed, S1, S2 and S3. Now if my workflow is like, first of all, where currently at which step my workflow is running, so you can see that yeah, S1 is completed, S2 is running. If there are some scenarios in S2, then you can check what were the issues due to which it failed. So let's say it called particular HTTP endpoint and it got a timeout error. Okay, so you have those details on the UI itself, so you can act quickly and understand those errors and debug them easily. Again, since this was like managed, this was a solution which was open source Conductor solution, open source by Netflix, but it was hosted it was hosted by booking.com, and there were some issues that which they encountered. They have to implement some customizations around it. First of all, like as a backend DB, this uses Dynamite. There was some, I think DynamoDB. It's their abstraction, Netflix abstraction over the DynamoDB. Okay. Similarly, they have their abstraction over queuing mechanism. So instead of using what conductor is relied on, they booking.com leveraged MySQL and then Redis. This is not Regis, this is Redis. Okay, Redis for queue mechanism, and there were for monitoring purposes, like as in like to push in all the metrics and all. They were using Prometheus. So they had to do some kind of custom management to host this conductor architecture. So again, there is management overhead which is coming in. Okay, and again, if you read this book, you will also understand when you could choose managed services which is provided by different cloud provider, and when you could use a solution which is created by you specifically, or it is an open source. So when you should host your own solution. Okay, so that's what we mean by, I mean, that's what you will learn if you go through this great, awesome book. So, what are the further improvements? Further improvement is booking.com specifically moved to AWS step functions. So, it simplified the architecture further. So, the idea is pretty simple. Okay, at place of this conductor, it just replaced with AWS step functions. Okay, so that's pretty much it. So in this case, since it's a managed service, you don't have to manage the infrastructure, whatever backend infrastructure it is using to host them, queue or anything. It's a completely a serverless solution which you can use to host your architecture. So it operational cost is removed from the booking.com's on-call persons, and it is completely moved to AWS. And also there's a great UI which also provides, which is helpful in debugging. And one thing which I missed, right? One thing which I missed was whenever you are executing these steps, S1, S2, S3. So whenever you are executing these steps, there's, let's say, this particular step. Okay. So at this time, you can introduce your retry strategy. Okay. You can introduce your retry strategy on these steps, that even like, let's say if some particular steps failed, at what exception or like what kind of scenarios it should retry for that exception. Okay, or it should completely fail that entirely, the complete step execution or the complete workflow execution. Okay, so I hope this video was helpful to understand some of the decision making around when you can choose your workflow kind of design to host your system. So I will meet you again with more such interesting topics. Consider subscribing MsDeep Singh, and then consider reading System Design on AWS on O'Reilly platform, as well as it should be available on Amazon and Flipkart. So we will meet again. Till then, stay safe. Tata. Bye bye.